This section we talk about quadric surfaces in a two-dimensional space. I think you learned that in the college algebra. We're talking about quadric curves. Okay. So in a three-dimensional space, we add z variable in. We got quadric surfaces. For example, if we have like x squared plus y squared equal to 1, in the two-dimensional space, you said, I know what's graph of that, which is a circle. Every point on a circle, the distance to the origin is 1. The same equation in a three-dimensional space. Let's see what's graph of that. You said, okay, it's a circle, okay, on the xy plane. Look at this equation. The z variable does not show up. Okay. So how about a circle like that? Say the point here, you have x, y, z. Since there's no z in this equation, so z can be anything. As long as x, y satisfy this equation, they should be, so this shouldn't be a circle anymore. This should be a cylinder. Okay, so whenever in your equation there's one variable is missing, then you got a cylinder, because in that direction you can be the one, whatever the missing variable can be anything. Okay, so this section there's not much theory. We just need to understand how to plot the quadric form functions, what you say. For example, we got something quadric function like this. Okay, what's the graph of that? First of all, I want you to understand all those quadric equations, their graph is a surface. Okay, remember it's a surface. So the question is, what kind of surface? Okay, now let's look at this. This is another example. What kind of surface is this? Okay, now if you let z equal to 0, then you get this x squared plus y squared over 9 equal to 1. We know that z equal to 0, that means this is the curve lies on the xy plane, so we know it's a ellipse. Okay, and then you let x equal to 0, so you got like y squared over 9 plus z squared over 4 equal to 1. This is another curve. Okay, let x equal to 0. Okay, what is x equal to 0? What is the graph of that? X equal to 0 is a plane. It's a YZ plane. Okay, so the original equation is a surface. X equal to 0 is another surface. Intersection of those two surfaces give you a curve like that. Okay, so which is another ellipse, okay, on the YZ plane like this. Okay, then you let y equal to 0. Really is something like this. Y equal to 0, and at the same time you got x squared plus y squared over 9 plus z squared over 4 equal to 1. This is two equations. Those two equations represent two surfaces. One is y equal to 0, which give you whole xz plane. So intersection of that give you x squared y equal to 0 plus z squared over 4 equal to 1, give you another ellipse. So you put these three things together, you can see you get something, we call this an ellipsoid. Okay. See another example. We want to see what this quadric function looks like. 4x squared plus y squared. First of all, remember this is a surface. Okay. Okay, now let's look at it. Figure out what kind of surface is this. Okay, now let's say z equal to 0. Okay. Look at it our right hand side. You got everything square, so the z cannot be negative. Okay, so your surface, there's nothing there below the xy plane. Okay. Let's start with z equal to 0. Z equal to 0, only possibility is x is 0, y is 0. So this point will be on the surface. Okay. Origin will be on the surface. Then we try z equal to 1. Z equal to 4x squared plus y squared. Again, these two equations represent two surfaces. Z equal to 1 is a plane, okay? It's a plane like this. Like this. And this one is another surface. We want to see what kind of surface is that. So combine those two, you get 4x squared plus y squared equal to 1. So intersection of these two surfaces give you curve. What is that? Is a ellipse, right? So it's something like that. Okay. Then you try z equal to 2. If z equal to 2, then you got this. With z equal to 2 is here, say. You got bigger ellipse. Okay. Then in this equation, you try this. You try x equal to 0, then z equal to 4x squared plus y squared. These two equations represent two surfaces again. Intersection of this give you z equal to y squared. X equal to 0 is a plane, which is a yz plane. So on the yz plane intersects your surface, you got z equal to y squared, which is a parabola. Okay. So combine those, you can see you got, we call this paraboloid, go all the way up to infinity. Okay. Now let's see another example. X squared over 4 plus y squared minus z squared over 4 equal to 1. Again, first of all, you have to remember this is a surface. Okay. So to figure out what kind of surface is that, you always need to if you can see the cross section, what is a cross section looks like, that will help you to understand the whole thing. So if I add z squared over 4 on both sides, we got this. We got this equation. Okay, now when z equal to 0, when z equal to 0, you got x squared over 4 plus y squared equal to 1, which is ellipse. Okay. Now, when z is 1, okay, say here, z equal to 1, you got the right hand side is bigger, so you got a bigger ellipse. Since z there you take a square, so z equal to -1, you got the same thing. Like that. Bigger, you got a bigger, and like that. And now, if you let x equal to 0, combine with this equation, you got x equal to 0 again. Is a plane, or you can say it's a surface. Plane is a surface. So you got a y squared if x equal to 0. You got a y squared minus z squared over 4 equal to 1, which we know that is a hyperbola. So we call this thing a hyperboloid. You need to read a book for the summary all kind of quadric surfaces. The last example is z squared over c squared equal to, let me make it simple, z squared equal to x squared plus y squared. So what kind of surface is this? Okay, for this one, 1x equal to 0, y equal to 0, z equal to 0. So this point will be on the surface. If z equal to 1, or z equal to -1, you got what? You got x squared plus y squared equal to 1. So with z equal to 1 is a plane, you got a circle there. Also, you got the same circle for the z equal to -1. If z equal to 2, then you got a bigger circle. Okay? You got a bigger circle. So this is pretty much like the question: what is the side surface looks like? Okay. So to see that, we let x equal to 0. Okay. Combine with this. Again, this is x equal to 0 is a surface. Z squared plus x equal to x squared plus y squared give you another surface. Intersection of those two surfaces give you z squared equal to y squared, which is equivalent to say z equal to positive and negative y. Okay. So x equal to 0 means it's on the y. This curve is on the yz plane. What is this curve? This gives you two lines. That's why this surface gives you a cone. So for this section, you just need to understand what is a quadric surfaces look like. So all the things here all those quadric functions represent some surface. Just like a 2D, they represent curves like ellipse, parabola, and so on and so forth. So here 3D is more complicated. To be able to see the whole surface, you need to understand what is a cross section looks like, especially with the XY plane, YZ plane, and XZ plane. If you can see that you know the cross section looks like, then you can figure out what is whole surface looks like.